week for week 18. You're going to need your book, and then you're also going to need your practice book, which looks like this. Okay, so in your book, you're going to need pages 106 through 115. And in your practice book, your workbook, you're going to need page 123 through, through 130. So you're going to use these to practice taking as we go through our notes in our textbook, okay? So let's look at what we know so far. There's some words in here that we are going to be looking at. We're going to be looking at slope, just like we did in our last equation. We're also going to look at the y-intercept. We're also going to look at proportional relationships. We're going to look at unit rates. And then we're going to look at the constant of proportionality, which you already took notes for. So that should help you with what we're going through today, okay? So let's read the word problem and answer the series of questions to help us use the graph to find the proportional relationship of the unit rate. And then we're going to study the relationship between the unit rate and the slope when the relationship is proportional and the graph is has a y-intercept of 0. Okay, so let's look at the page first and work through this one together. It says you know how to identify proportional relationships in linear functions. Take a look at this problem. Only the top runners in the world can finish a marathon in close to 2 hours. This graph shows the pace that one such runner followed in a race. What is the unit rate? Okay, so let's answer these questions in order to solve this problem. First, it says write the coordinates for points A and B. Okay, so I'm looking at the coordinate here. I'm looking at the coordinate here. My coordinate for A is 24. Remember, my x goes first. So for A, it's 24. And for B, it's 48. Okay, now it says, how do you interpret these points in terms of numbers of miles run in a given number of minutes? Okay, so what they're basically asking is, how are you interpreting this from miles to, like, what do you call that? We're gonna say the runner runs 4 miles in 20 minutes. Okay, and then he runs 8 miles in 40 minutes. Okay, question C asks, how can you use the information above to find the rate per minute? So I'm going to divide the number of miles by the number of minutes. Okay, it says find the unit rate and show your work. So I'm going to divide that 40 by 20. Okay, and I'm going to reduce that because 4 can go into 4 once and 4 can go into 20 5 times. And I'm going to divide 8 by 40. Okay, and 8 can go to 8 once. 8 can also go into 45 times. So my unit rate equals 1/5. Okay, now it says, what does the unit rate mean in the problem situation? It means that the runner runs 1 mile, 1/5 of a mile in 1 minute. So just from this graph, we know that the runner runs 1/5 a mile. Okay, that answers the question. Unit rate means that what I want to find is what happens when they do it in one measurement. So in this case, I want to know what they're doing in 1 minute. And for 1 minute, we know that he runs 1/5 of a mile. Okay, so that's what we know. Let's find out a little more about it. Okay, next page, page 107. We're going to review how to find our slope by visually finding the rise over run, as well as the slope formula. So let's compare the slope with the unit rate from the previous page. And then let's talk about why the slope and the unit rate are the same value. It says the unit rate can be represented in a slope of a graph. Compare 0, 0 and 24 in the graph in the previous page. It shows that the rise is 4 and the run is 20. Okay, so we're taking a look at that graph again, and we know that the rise, that first rise is 20, okay, and then the rise is 4 and the run is 20. Okay, so your rise over run is your equation, and we're going to do 4 over 20, or we can reduce that to get 1 over 5. Okay, so you can use the 2 points on the graph to find the slope. Use the formula below with 0, 0 and 2, 4 to label one of the coordinates x equal x1 and y1 and the other coordinate as x2 and y2, and then we're going to substitute the values for the variables. Okay, so this is my first equation, 4 over 20. And then my second equation is we're going to just use 0, 0 just to make it easy for us. Okay, so that we can subtract 4 minus 0 gives me 4, 20 minus 0 gives me 20, and if I reduce that or simplify it, I get 1/5. My y-intercept of the graph of the previous page is 0. The graphs of all proportional relationships include the point 0, 0 so that the y-intercept is always 0. And that just makes us, when the y-intercept is 0, that just makes it easy for us to be able to figure out what our slope is. So you've seen the equation y equals mx plus b. Okay, we've used this equation many times in the previous unit. M is your slope. B is your y-intercept. So your slope is in the green, your y-intercept is in the purple. The graph shows proportional relationships also fits in this format, but the value of b is always 0. My y-intercept, once again, they're saying b, this number right here, is always going to be 0. So let's look at the equation for the graph on the previous page. Okay, we have 1/5 x plus 0. This means that all proportional relationships are linear functions in which when the y-intercept is 0. So what they're saying is whenever this y-intercept is 0, you're always going to have a linear equation. This y-intercept, this y equals mx plus b, this equation right here is always going to be a linear equation. We're going to call that a linear equation, okay? So down at the bottom it says reflect. Explain how it's possible that all proportional relationships are linear functions, but not all linear functions are proportional relationships, okay? So all proportional relationships are linear functions because they can be defined as an equation. Okay, so if it's a linear equation, it's always going to look like y equals mx plus b, no matter what. Okay, that's what our line's going to be, where our b equals 0. Okay, so there are other linear functions where the y-intercept is not 0, so these aren't proportional relationships. So the only time it's a proportional relationship is if your y equals 0, your y-intercept is 0. Okay, and we've talked about this before. If it does not go through its origin, meaning on this graph, if this red line right here does not go through 0 right here, okay, then that line is not a proportional relationship. So a non-linear non-proportional relationship is when the y-intercept is not equal to 0. Anywhere else on the graph, if that line hits anywhere else on the y-axis, that means that it is not a proportional relationship. So all linear functions are not, all our linear functions are not proportional relationships unless it goes through 0, our origin. Okay, so on our next page, let me see where I'm at on my time. Okay, so let's review and then let's look at the next page and learn a little bit more about using tables, graphs, and equations.